Yes. I think that's working now. I was hoping I could pick your brain, Matt, today on ROS messages for steering and transmission control. Jeff, did you have anything on your list that you wanted to talk through?
I don't think so.
Matt, did you want to jump into anything, or can I jump into talking about ROS messages?
That's great. Yeah. ROS messages.
I do want to interject one thing. It's a good thing we went through the whole thing with my lights at the last Tuesday meeting, because I didn't realize that the last Friday meeting where I talked about it didn't get recorded. So it's a good thing that we went over it again and got that online. So Al can't go back and watch the one from last Friday because we didn't do one last Friday. And we had lots of secrets there.
Matt alluded to the fact that there was, great and wondrous things that were discussed last Friday. So I think there was a special acronym for that. Was it BS? I'm not sure. You have to tell me later what that acronym stands for. So can you see my feeble attempt writing some stuff down? Let me see if I can move that out of the way. So I don't know where to begin, but I was trying to actually put down on paper what each of these, as you may recall, I'm trying to go down the path of having a Teensy that controls the steering motor controller board and takes input from an angle, sensing device. A Teensy that is tracking, recording speed both on the left and right wheel, and all of that is feeding into the data bus, including the joystick. And there's a Teensy that is taking information about actual speed and target speed and calculating, what do I have to change on the super servo in order to get to this, the target speed. So at a high level, that's my, both physical and logical layout of these microcontrollers. We could debate that. The primary reason as to why I'm doing that is I'm hoping that USB connections are less noisy than having signal wires, whatever, 10, 24 inches long. So I was trying to write down, okay, so I've got a steering angle Teensy. What is it going to take as input? I've got a Teensy that's controlling the transmission servo. What is it going to take as input? Got a joystick over here, outputting stuff. How is, ultimately what is actually getting in the data bus that then gets fed to these other guys. I'm going to stop for a second and say, any questions about what I'm trying to do? I'll take that as a no. So let me ask some simple, hopefully, but discrete questions. So I've got this joystick plugged in, and it's going to produce, a command velocity message. And from previous conversations, I think that needs to get translated into Ackermann messages. Is that a true statement?
Well, what we do is we just use a standard command velocity, but the field that says rotational speed, we just replace that with a steering angle. So we essentially just cheat, and that's basically comes from the fact if you run Tab Planner and you set the flag saying generate a steering angle as opposed to rotational velocity, that's what it does. It just changes the meaning of the second field in that. So as far as I know, we don't actually convert anything to an Ackermann message. I've seen it floating around in the directories, but I don't think we actually do that. So you can do it either way.
So feeding something into your microcontroller that's going to control your steering motor, that's going to control the steering, what message are you pulling off the bus to actually...
We just have a command velocity message, so you subscribe to that, and you just have to know that the second field is actually steering angle as opposed to rotational velocity.
So here you're reading command velocity, and it's rotational velocity, but it's not really rotational velocity. It's steering angle. What is?
Yes, that's basically what we're doing. Yes. Now back to what you were saying. You could convert command velocity into an Ackermann. Under Ackermann messages, Ackermann drive stamped, and you say does the Ackermann message have two fields or just have one field here where you're showing the steering angle?
I think there's actually 4 fields on it. I'd have to pull up the documentation.
Okay. Anyway, you could do that. You could convert, if you wanted to, you could convert command velocity into an Ackermann message, and that way things they'd be consistent then. So when your steering says read the Ackermann message, yes, it would be a steering angle at that point.
Matt, any input?
Yeah, so the way that I have it set up is like what Jeff is saying. So in the TEP planner, I send out steer angle, and then I just listen to command velocity on the Teensy.
So forget Ackermann, we're only using command velocity into the steer angle controller.
Yeah, and so I think that the command velocity is range bound to like minus 0.3 and plus 0.3. And then I just map that to the steer angle, lock to lock, not steer angle, but yeah, lock to lock on the vehicle side.
And Jeff, you probably said it and I just didn't write it down fast enough. Is it rotational velocity that you're within command velocity message? What was the data?
There are 2 fields. The first field is forward velocity in meters per second, and the second field is normally rotational velocity in radians per second. But we just simply treat that as instead of rotational velocity, we just call it steering angle.
Okay, and Matt, you're taking that and mapping this -3 to +3 to.
You could put that +/-3, and then it'll make more sense. You can put real big plus and minuses in there. There you go.
Why? I don't know why you made me change my font size, but
I hate fighting with these programs to get them to do what you want.
and so you map that to a PWM. I'm going to call it signal, although it's probably not technically a signal, but Matt, that's what you do. You map that then to the microseconds that you end up sending to your steering controller board.
No, basically it's a closed loop control inside of your microcontroller. So you send it a steering angle, and then you get your angle back from you're saying raw angle there from your sensor you've got, and you compare those two together, and then the error between that you run the motor one direction or the other. So you don't convert the steering angle directly to your drive power.
Okay, and so then I'm jumping to the conclusion that what's actually coming into the transmission control is the first variable of command velocity, right? It's the um, something about speed.
Yeah.
Over here.
Linear X.
And is it a plus and minus 3 as well, or 0.3? Plus and minus 0.3 as well?
It's just meters per second. But it's not range bound.
Okay. And inside that, this is inside of, this is where you're gonna, where I would do the, here, that's the actual and the adjustments. Okay, I guess that clears it up. No Ackerman in this process. It's just off command velocity.
Yep.
Probably, I have more questions, but I don't know what they are at the moment. Somebody put something in the tab. Oh, so the tab planner. So the tab planner plays into this. How, in your mind, Matt, or in reality?
Well, the TEP planner is going to output, so move base is going to output command velocity.
So the joystick actually isn't producing, I mean, if I'm doing it in manual mode, the joystick is doing that. If I'm in auto mode, then the tab planner is doing that, right?
Yep, that's where we use the command velocity mux. And so you can control with a joystick or control with the move base.
So I think what you're saying is, let me move this over here. And then bring up the box. Not sure why I can't. Okay, fighting, don't like fighting. There's so many ways to. So effectively, you're saying both of these are going to go into a mux. And one of them wins, right?
Yep. I'll send you what that looks like.
Something along those lines.
Let me see. Yep.
Because I don't know where I came up with Ackerman was in the middle of all of this, but I guess I would say I had the wrong end of the stick.
So this is the command velocity mux. So it's simple drive. and it will listen to each one of those and then prioritize. Now, Solon is working on the obstacle detection system, and so we'll also have the obstacle detection system feed into there. So kind of what the thinking is on the priorities is that the human would be the highest priority. You can always take control of that. And then the next one would be the safety system. And then the lowest priority would be the autonomous system.
And so the simple drive you're saying provides the MUX.
Yep. That's the package that we're using.
And make sense? Right? I mean, that will go into the MUX, or that will sit someplace else in the chain?
It's just different. So you see on the right-hand side where you have the TEB planner with the arrow over and the joystick and the arrow over,
Yep.
Safety would be another one. So safety and then an arrow over.
Right.
Okay.
I just didn't have a box around.
Okay. TBD. Sorry. Oh, I thought it said TEB. Yeah, to be determined. Safety obstacle system. Yep.
Okay. Well, that's probably enough to keep me busy for a little while. And
So you want to look through that. Mm-hmm.
Go ahead. I'm sorry.
What was that? I was just wondering if you want to, do you know how to set up your system to map your lock-to-lock and map that to the command velocity message, Angular Z?
You mean to the code to do that mapping? Yeah, I think so.
Okay.
Probably have a sample of that someplace.
Matt, do you have a clever way to do that?
It's on the Google Drive under main.cpp. It's not clever. I just use the same mapping function. So just map the 0.3 value to your full lock. So like on your robot, you find where your left lock is, where your right lock is, and where center.
So you didn't have a clever way to figure out what that angle is to measure it. You know, we were talking about one time you could set your drive to say full left and then drive in a circle and then do some measurements. And I just wondered if you'd come up with a way to do that kind of procedure type stuff.
No, the calibrating, creating a vehicle model, I don't.
Okay.
I mean, at the moment, my I mean, this was just a testing Can you see the
Yep.
note that I pulled up? So for me, I mean, this was to test to, let's see, what did I take in? Take in command velocity linear x. I'm trying to, then I would do map double, and this was the fancy math to do, to map it.
Yeah, so there's different, okay. On your velocity, it's kind of like a motor, but I guess it gives you the number. Yep. Okay. The servo is a little tricky. I need to redo that. So for your velocity, you have your neutral, full forward. One other thing you need to know is like friction. So take your robot out, because let's say 1500, hypothetically, if 1500 is neutral, what you'll find is that you really need to go to like 1800 before your vehicle will move, because there's just friction, or if you're out in the field. And
Right.
so you'll want to actually start your PID controller from that point, instead of starting it from 1500.
Yeah, thanks for that. It's been interesting testing the Super Servo. I find it to be very consistent in delivering pounds of torque on back to microseconds. So I can say like whatever 1500 microseconds is 40 pounds of torque, and it just will do that all day long.
Yeah.
But if there's not any torque on it, 1500 gives you crazy settings on the actual sweep of the servo arm. It's pretty interesting. It's almost like it was designed to deliver consistent torque at a certain level, not positional. It's not a positional servo at all, I find. It's at least that's my takeaway. So anyway, this was my test code in my, how do I map, whatever is coming in to a target. But this is all just theoretical because I haven't driven the dang thing. And I don't remember how I came up with that math, but there's the math on taking one input and outputting another mapped variable, if you will.
Yep. So I don't use the servo on the transmission. I don't use the servo by position. I just get the feedback from the velocity and then increase the millisecond or decrease based off of speed. So it's just constantly being adjusted.
And I will have to borrow that code if that's in your main CPP.
Yep.
Haven't gotten to that point yet. This was all back in the day when I thought it was a positional servo, not not what it is. But anyway, that's where I'm at with that. And Simple Drive, you put Simple Drive up here in the chat. Where does that fit into the picture?
So Simple Drive is that command mux command velocity. So it switches between your teleop, your safety system, and move base.
Oh, I'm picking up now. Both URLs are referencing Simple Drive. Got it.
So one's a wiki page, but the Google Drive has the wiki also, the information that's on the wiki.
Cool. In your PID is also in your main .cpp, right?
In there, I'm just running one teensy.
And you handcrafted your PID, right? You're not using anybody else's PID.
Oh, yeah. I don't know if it's actually a bit, but we could use a real one like a library or something and then get better results. It seems to hold velocity pretty well. And the steering seems really smooth also, so.
I'm just opening up your main. Oof, that didn't word wrap. That didn't work out well at all. I opened it up and it's just one big conglomeration of, there's no line breaks in this package that I opened it up with. Bear with me, I'm starting to open it up with something else. And now, of course, I can't find it. Oh, there it is. Yeah, that's a little bit better.
I've noticed on Windows, if you run into that situation, if you open it with WordPad, you got Notepad and WordPad were the original editors, and WordPad usually is smart enough to fix that when you open it.
Yeah, so I just went right to Word, and it's legible here. Matt, do you remember where here's what I'm looking for, you just increase, if the speed isn't what you wanted and you just increment your, I'm gonna call it your PWM. Do you recall where in your code that is?
Right there, is that it? Or that's the steering. So it'd be velocity, wherever it says velocity. A little bit farther up. So that sets the velocity to 0. Velocity control function is a little bit lower. Or up. Yep, right there. Okay, that's a different one. I've upgraded since then. I need to check in the new version of that file. But yes, essentially, if the speed is too low, compare it to that, and then increase the position of the servo.
And how much do you increase it by? I'm just looking to see.
So this one is actually with a linear actuator and not the servo.
So this was positional in nature, right? Okay. Don't look here. Don't look at that. Look over here. So how was St. Louis?
It was good. I went to one session and I thought it'd be a good experiment for you. They strip planted some different forage crops for cows, and then they had different paddocks, and then they just watched what the cows ate. They flew a drone over and then recorded plant vigor, and then you could see
to see what they preferred.
Yeah, see which one they preferred. Yep.
And the answer is,
Well, I don't know if it depends on the cow or the region, or which how that works. But I don't think they showed the crop. They just showed, this was kind of from a drone company showing what you can do with it. But I thought that was a pretty cool test.
yeah, that is an interesting test. But if you ask humans what do they like to eat, they'd probably all
Okay.
have to crunch, right?
Yeah.
I'm sure that's the most healthy thing for us to eat.
Good point.
Jeff's probably a Frosted Flakes guy, but no reaction.
So if you're going to check your cows, you have to have a crop of Captain Crunch that you're growing.
Oh, actually, I'm told that grains are the what puts on weight the fastest, both for humans and cows. That's why we shouldn't really eat grains as humans. But I digress. Any other interesting things that you saw?
It's just it's a lot of information, a lot of people doing different tests. It was interesting that the variable rate. First time, yep.
How many people? Tons? Not so many?
A few hundred. I don't remember the total count or if I ever heard that, but it was pretty packed. Maybe 500 to 1,000.
Were the big OEMs there?
Yes. Yep.
What could you decipher from their interest or their why were they there? Would you guess?
Well, John Deere had a booth, and they were there just to represent and to communicate with the growers or producers. And there was a company from Brazil that has a pretty fascinating product. It's called Alice. It's Alice.ag. I think it's an AI system that does like logistics around the farm and gives farmer a lot of information. They're out of Brazil, but they have, I can't remember how many acres they have in their system now, but a huge amount of land. Now they're moving to the US, and so people are trying different techniques to make farming more efficient. That's kind of what the theme was, obviously. A lot of drone companies there.
Their value was more bushels per acre. How?
So different examples. For example, like micro weather. So if you have a choice between 4 fields, they'll do logistics for you and say, well, there could be a rain event in this field, so you're better off going and spraying this field because your herbicide needs at least 2 hours before it gets rain, and so you can keep your vehicles moving. You can keep working.
Wow. So they were anticipating changing your suggested work for the day based on anticipated weather.
Yep.
Cool.
Yep. So kind of logistics, using smart logistics. And then also a machine. So they have like a CAN bus. They clip onto your CAN bus, and then they're recording all of that data so they can use that.
Did you give a talk?
I did. Yeah. I tried to talk a little bit about ROS and the power of the software and the available packages.
What sort of questions do you recall?
There were a few of them. There were people that were wondering about the levels of autonomy. So there was a panel, not specifically to me, but so after there was 3 speakers in this block, and then we had a panel, and people were concerned, or one question was around the levels of autonomy. The other one is the concerns around safety. How is that being handled? How are we making sure it's secure? So ROS 2 has built-in authentication. So each of the nodes, when they communicate, you know who you're talking to. most of the time we handle the safety system or the encryption part, just like a home network. You're encrypted as you're talking to your provider or from your vehicle to your base station. That's under encryption, but normally on the vehicle, that's open. Whereas ROS 2, each individual node is encrypted and authenticated.
Did you demo your tractor?
Nope.
Did
No,
you take
Rogo was there. They demoed theirs.
What did you think?
Awesome. Yeah, they're doing great work. It's cool.
Cost?
I'm not sure what their cost is for the soil sampling. Also, Smart Ag was there. Rogo.
ROGO?
Yep. So they do autonomous soil sampling. That's the skid steer robot.
Rogo Ag. Holy cow, they're doing that with a Bobcat?
Yep.
That looks like a serious device.
Smart Ag was there. They do the grain cart, autonomous grain carts. They have a really cool system. Looks like their system could be for sale next year. They're anticipating around $50,000 for a kit, for an autonomy kit.
And so you add it to existing equipment.
Yeah, there's a series of John Deere tractors that it will bolt to.
And do they use
No. Rogo does, but not Smart Ag.
I'm just looking at their website. Colin Hurd.
Yep.
And he's a member on the Ross Agriculture Slack group. He hasn't been on for a long time, but he is a member.
Cool.
A lot of work being done around like ag tech hubs and like incubators and kind of integrating education, farmland, industry, startups, and education.
Would you say, I mean, what percentage of folks were actually producers?
That's a good question. Because a lot of people may be producers, and work in another one, maybe they're an agronomist and have a farm too. So there may be some mix. I don't know, maybe 20%. That's a guess. I actually have no idea.
Mm. Jeff, how's Sammy coming?
Well, I drove it, and it seems to work. In fact, last night after I got my beacon put on there and played with it, I decided to take it for a drive to see how it works inside of the building. I'm not sure I can turn sharp enough to go around, the hallways and whatever. And the first thing I noticed was as soon as I fired up the drive system, my beacon stopped flashing. So there's some conflict in software there I got to track down. And I was driving it around and I got to an open area. And I thought, well, what kind of turning radius does it have? So I cranked it over and started driving. It was maybe 6 foot diameter circle it was going in. So it was actually turning sharper than I expected it to. But that's why I was asking about doing calibrating the steering, because I'm getting close to that point where I'm going to have to know how to do that. And it looks like that. Even at that, if I just, inside of a building, just drive in a circle and then kind of estimate where it was, that should be close enough to tell me that. And then at the last on the last meeting, I was talking about the LED strips, and I just happen to have. Here's this one is, when you buy them, you can get either the white or the black background.
Right.
And this one happens to be 60 LEDs per meter. So that's the spacing on them. And then you can get the higher resolution ones that are like this.
Oh,
This is 144 LEDs per meter. So basically, mine is about a foot long. So that, I think I counted them, and that's going to give me about out to, because I got like 12 inches across the back. So it's going to be about like that. I could have that many LEDs. I think I counted there's like 40 to 42 LEDs in that amount of space. And if I use the other one, that's the lower resolution. So again, here's the white one, and here's one that's black. And when you buy them, I see the white one doesn't have any adhesive or anything on the back of it. It's just a strip with LEDs on it. And here's the black one, and on the back of that, it's got an adhesive strip. So you just peel it off and stick it on. And then this one, that's the high density one, is actually inside of a silicone jacket. So I don't know how you hook this on, because I doubt if glue is going to stick to the back of the silicone. So I don't know how to actually hook it on. But this, I was just thinking about taking this and cutting it off at a foot and sticking it on there. And they're directly interchangeable. It doesn't matter which resolution I have. You just go to the software, tell how many total LEDs you have. And one more thing I noticed, I was looking to see right here, when you buy these things, see right there, there's a splice. So when they get this big roll, they when the roll runs out, they just cut it off and splice it onto another one. So when you get it, it's a continuous piece, but sometimes they do a really hack job of that. So your spacing is weird in between. And I was noticing even the high density one here. There it is right there. See, it's got a splice in there too, and so there's just a slightly bigger gap right there than everything else. But depending on what you're doing, you may not care enough to worry about it. So, and when I do mine, if I do my 12 inches, it's going to fit within. I don't have any gaps or anything in there, so that should work out. And I was hoping to have that running for today, but I didn't get around to it. I got my beacons flashing last night. And then, so for next Tuesday meeting, I'll try to get one of these LED strips running just to show that you really can do it, and show that it's fairly easy to do, and maybe come up with some demos on how to get it to, the different things I was babbling about at the last meeting with all the different modes you could make it do.
that's a lot of visual clues to have with that dense one you have there.
Yeah, I see Jim's trying to get on. Somebody should answer him. I guess we could all answer him. Let's see. We'll find the link. It seems to confuse people that it's either not the meetings aren't posted, or they can't find the. Here. So let's copy this link and send to him.
If
Okay, so let's see. I forgot what we were doing here.
oh,
I posted the link for him, so maybe he'll be on.
Jeff, talking about calibrating that steer angle, I was wondering if you've seen this article on Medium. He goes through on how he calibrates that arc to get the steer angle for the robot.
You saw that where?
I posted the link in the chat, but it's on Medium.
I haven't seen this yet. I can take a look at that. I think the guy on Ag Open GPS, which I got the name right this time, but he's got a video on how to calibrate the steering too. So he's got some kind of procedure to do it. So there should be enough to come up with it. Otherwise, I'll pull out my protractor and try to figure out what the angle is at the two extremes, and just go from that. But I keep thinking that if you get to that point where it's drivable, and then it just occurred to me Jim hasn't signed on yet, so I don't know if he didn't get that or that link should have worked. So anyway, what was I saying? Once you get to the point where it's simply drivable, then you could either have it drive in a circle and manually measure it, or if you got the GPS running, you should be able to figure out what the diameter of that circle is. So you could do this, somehow you could do this automatically, where you just take it out and say, do your calibrate, drive in a circle, and then take the diameter of that circle, take the max and the min at some point, and that should give you the diameter of the circle, which gives you the radius, and then you should be able to calculate back and figure out, what is the steering angle at that point. So that's something that it would be real handy to have lots of different calibration techniques like that, where you don't have to go manually pull out your tape measure and your protractor and your chalk and do all this kind of stuff. So that would be real handy to have that. We got all these fancy sensors. We might as well take advantage of them. Hi, Jim. I see you made it.
Yeah, I made it. So as far as this happens noon Eastern time on Fridays?
Correct.
Okay. 10 o'clock my time. Okay. Normally, like on the other channels, the notification shows up. I don't see the notification. I think that was my question. Do I need to change something in my setup?
No, simply because nobody posts one. That's why it doesn't show up.
Oh, okay.
How do you do that, Matt? I thought it was an automatic thing because it always comes out at precisely 60 minutes before.
I just posted in there. I think we could probably get I could look for a Slack bot, and then it could just post it in the channel.
Oh, you're manually doing that.
Yeah, but I should automate it, right? This is robot world.
No, I thought the trains could set their clocks by it when you do that. I thought it was coming out exactly 60 minutes before.
Sometimes it's a little late if I get distracted.
Al,
I saw your post there on processing outputs through the Teensy. I was curious. I just hadn't comprehended why there was a reference to speed for the steering.
Why is there a reference to the speed?
Calculate microseconds to reach target steering angle.
Yeah, steering angle on the left, speed on the right. This is so I've got two things going on, or multiple things going on in this chart. One is the transmission control and one is the steering motor control. So if I said anything about speed over here on steering, I was goofed up and not right. It was, it's about heading and steering angle.
Translate that, he's saying that to generate his PWM for his motor driver board, he's doing it with figuring out how many microseconds the pulse width should be, and that's why he says calculate microseconds. So he's actually saying he's generating a PWM without using a PWM command, I think is why. That's what I took out of that.
Right, because the statement, at least the one that I'm using, is a right microsecond statement to actually control the motor control board.
So just that statement makes sense to you, but anybody else looks at it and says, what is he talking about that? Why do you have to know how long it takes to do that? So that's why he was confused, and that's why I was confused, and I thought about it for a long time and then figured out what you're talking about.
In my concept so far, and this is very uneducated, I do like the idea if you are very close to an angle request, say you're at 89 degrees and you want to go to 90 degrees, would this calculation do it slower than if I was at 5 degrees and wanted to go to 90 degrees? Would it drive it at a higher rate?
Higher rate, yes, the value is going to be higher than.
Right, so it would actually be a quicker turn versus a very slow turn just to go 1 degree?
Well, the speed, for me, and Matt or Jeff are probably more seasoned at it than I am. I mean, the bigger the angle difference, the bigger the value that this is going to be. The speed at which the motor reacts, I think, is a whole nother conversation. I think the control board that I'm using here, the Citron control board, you have the ability to not only give it a different value here, but you also have the ability to give it what I'll call an aggressiveness value. This is suggesting the speed of, or the aggressiveness of the motor stays constant.
How often is this recalculated?
Well, it's going to do it at the speed of the board or the speed of the frequency of the data coming in. I mean,
Okay.
100 times a second, maybe.
So its aggressiveness would change as it gets closer to set point. It would slow down. The farther from set point, it would speed up.
I would say technically no. It's when you're running a PID loop, when you get off by a couple of degrees, it's going to go and saturate the power of the motor anyway. So if you want to control the speed, you put a ramp function in there. So basically, you say, here's my target angle coming in, and here's my, or say you start off at 0 and you say I'm going to go to 45 degrees. What you can do is you can have it so up front you can put a ramp on that, so it's slowly. Where's my camera here? So it slowly ramps up like this instead of going just a step function like that. So there's other ways to control how it's going to do that. But typically, if you see internally, you got a loop running that's saying take the current angle that you're sensing, and here's the angle that's requested, and you subtract those two, and whatever the error is, you generate an amount of power to run the motor based on that. And as they say, once you start cranking up your gains, you only get off by a couple of degrees, and at that point you're putting full power to the motor anyway. So you have to back off and say, okay, how can I control to control the aggressiveness? You want to say move your target angle slower, even though you came in with a step function. You want to then put a ramp on that so it slowly moves the point one way or the other. So in reality, it's very aggressive at 1 degree, and it's also going to be more aggressive out at 30 degrees, but you just don't change it from 0 to 30 as a step function. You say, I'm at 0, let's go to 1 degree, 2 degree, 3 degree, 4 degree, and then have it aggressively track that as it moves out. So it's really just a matter of how you implement it internally, and once you put it together and say, boy, that's really wild steering, and then you go in and put these other things to calm it down and get it to do what you want.
That's in the standard PID calculations, correct?
No, actually, you do it. The PID just simply says, I need to be here and I'm here. It just generates the power to do that. So it's really a level above that. You have to decide as you're tracking the position back and forth. So it's really a layer above your PID. So the PID is doing everything it can to keep it right on the position where it thinks it needs to be. And it doesn't care if that's 1 degree or 30 degrees. It's going to try as hard as it can to get there as fast as it can. So it's up to you externally, a layer up, to say, okay, don't give me a step function. Take that step function, break it into little tiny increments to move it one way or the other. And once you start playing with that, those kind of things become more obvious.
Yeah, I'm going to share with you, Jim, can you see my screen?
Yes.
I mean, so this is about as simple as it gets on controlling the Citron motor driver. And in this command, you get what PWM, well, you get a motor speed and you get a direction. I think what Matt will tell you is in his code, he has set his motor speed to be constant. So the speed, technically the speed that motor is operating in is constant, but the actual PWM signal can change.
Oh, okay.
So, but I think, again, others might have better come than mine. The Citron gives you that, it gives you certain variables. Other motor controllers are going to give you different variables.
I was familiar with temperature control with PID, where you have a deadband or a pre-described, say your set point's 100 degrees, your deadband is 10 degrees. So that deadband floats around the set point and then controls the pulse width or the rate the contactor is cycled on and off, depending how far from set point it is. It looked like that slide that you presented on your logic, where it's looking at that differential, could do that, give you a variable output depending on how far from set point it is. That's what I was after.
Yeah, if you look at Matt's code, I'm trying to pull it back up here quickly, or at least one version of.
Jim, have you heard the term hysteresis?
Correct. That's what deadband and hysteresis are. What are I'm using the same term.
Okay. This just may be nomenclature, but I would separate those two terms.
Okay.
And sometimes we refer to a deadband as, for example, if your vehicle is not moving and you need it to go forward, you have to apply motor pressure to a certain point to break friction. And so that sometimes we refer to that as a deadband. And then once your vehicle is moving, then you can just use that tighter control.
Okay.
But there'll be a period where you have to add extra effort. And sometimes a deadband is on a joystick is like around 0, where you need to move the joystick a little bit more before it engages. Whereas a hysteresis is going to be something, the way that I understand it, is something that it's a certain distance away from your set point, and then you want to start to engage.
All right. So I guess back to the question on Al's little block diagram, with that part of the equation where it is looking at how long it would take it to get there. Is that attempting to do a hysteresis type output?
I've not actually written this code yet. I was going to look at what Matt had done. I was just trying to get clarity on what the inputs were, what the ROS topics were. So I don't have this code yet.
Okay.
Personally.
Yeah, so I take a look at the error, and if the error is within a certain amount, I don't adjust it, and that's a little variable. So, yeah, so you compare what your set point is, and then you compare what your current sensor value is, and then whatever that error value is. If it's within a certain range, I don't adjust it, because your wheels will jitter, you know.
Right.
Guys, apologies. I've got to get back to my day job.
Would that be a good tutorial on setting that up?
That's just where my mind is right at the moment is all.
That's good that you have that background. You can help us get that all tuned up.
Until I get some practical application, I don't know how relative it is to the actual performance. You know, like you say, we're all trying to get away from jitter and just want it to home in on the straight line.
Jim, have you happened to have bought a motor controller and a steering control motor yet?
I've got two applications. Excuse me. I've got a differential steer unit that I'm using just for education. I haven't attacked my Ackerman steering unit yet.
The reason I ask is because for me anyway, just hooking up the motor controller to the motor and sending it some commands and seeing the difference in its behavior was useful for me, again, just to get my simple head around how it all sort of works.
Yep. Yeah, I've got the two Citron boards that I'm interfacing to the differential steer unit right now.
So you've actually got something that you can steer as opposed to, I mean, well, the way I started was just literally just a motor and the controller. That's cool. Well, gents, I'm going to have to draw a line under it here for me, and I will try to get some more work done this weekend and document it as I go and share it like I do everything else. It's
Awesome.
all just a combination of crazy notes for me at the moment. But I am hoping to make a little bit more progress, so we'll see how we do. I'll send you pictures.
Awesome.
Nice to have you back, Matt. We'll talk to you later.
All right. See you guys.